Reverse chain. We know that by the chain rule that if, for example, we have y is 5x plus 1 all cubed, then dy dx is 15 times 5x plus 1 squared. Now let's just remind ourselves how we did that. So we had y is 5x plus 1 cubed. We differentiate the outside function, which is the cube. So we have 3 5x plus 1 squared. But then we have to multiply by the differential of the inside function. So we multiply by 5. And that's how we get the 15 5x plus 1 squared. It follows that if you integrated 15 times 5x plus 1 squared, which is of course this, then we'd get 5x plus 1 all cubed plus the constant which we've discussed. And further that, if you integrate 5x plus 1 squared, you'd get 5x plus 1 cubed over 15 plus a constant. All I've done here is divide both sides of this by 15. But another way of looking at that is 5x plus 1 squared dx. You integrate by increasing the power by 1 and dividing by the new power. But you also have to divide by the differential of the inside function. Up here, we multiplied by the differential of the inside function. But integration is a reverse process. Therefore, we divide. So in the denominator, the 3 is from the new power, and the 5 is the differential of the inside function. We know that when we differentiate using the chain rule, we multiply by the differential of the inside function. For example, if I differentiated this, then the outside function gives me 20x cubed minus x plus 3 to the 4. And then I multiply by the differential of the inside function, which is 3x squared minus 1. Since integration is a reverse process, it might seem sensible that we would divide by the differential of the inside function. But the next thing is of crucial importance. This is only the case if the inside function is a linear function, i.e. a function of the form ax plus b. It does not happen in any other situation, which is why I call it reverse chain in quotes, because it's not really a reverse chain except in this specific situation. So, for example, if we integrate e to the 2x minus 5 dx, where we have a function of this form, the differential of that inside function is 2, and indeed we do get e to the 2x minus 5 over 2 plus our constant. But if you have this, where the inside function is not linear, then it is not equal to this. You cannot, in that situation, divide by the differential of the inside function. And as I mentioned, that's why I call it the reverse chain. And in class, I would make the little quote signs with my fingers when I say reverse chain. It only works when integrating functions of the form f of ax plus b. We will consider this in the examples that follow.